Our speaker is Nick Mitchell. This talk is going to be a little bit different. What we're doing is we have this thing, it's called a chess clock. And here's how it works. We have two sides. Either side says 20 minutes. The left side belongs to our speaker, Nick. The right side belongs to you, the audience. We are going to let the left side begin to run, and we're going to give Nick 5 minutes to begin his talk with no interruption. After that time, I'll pause very briefly and see if there are any questions. If not, we resume with Nick. Henceforth, anytime any of you has a question, we interrupt Nick's clock, we turn the clock over to you. We let you ask your question and Nick responds. Once Nick is done responding, Nick resumes his lecture. You have 40 minutes total. Okay, I think we all get it. I think most importantly, Nick gets it. Okay. All right, Nick, when you're ready, we're going to start, and I'm going to give you 5 minutes. Okay, ready?
I'm good? Okay,
we're
great.
good? Okay, go.
Okay, so the point of this is let's make this as interactive as you guys want it to be. I left a room we can give live demos. I can deep dive into lots of different subtopics, performance, implementation details, or we can stay at the level of the programming model, so we can guide this in whatever way you guys want it to go. Oh, thought it was off mute. Maybe I'm not speaking loudly enough. Okay, I'll try to speak more forcefully. So as I was making this talk, you notice I've already rearranged the title a little bit. So serverless programming, you may be aware of. How many people are serverless programming? Know anything about it at all? Awesome. Okay, great. How many people are users of it? Awesome. This is great. Okay. So I'm speaking to a friend. Whoa. I guess I got mid-hot. Speaking to a friendly audience. Okay. So I think as you guys probably realize, people with a serverless background realize, is that there's, as usual with any new part of the world, there's no magic here. We're really solving, it's an iteration of an existing world. I think this is the way I try to summarize the basic layout of the talk as we go forward. The point of it is serverless consists of lightweight functions, but they're not the entirety of the programming model. The idea is that we can program the cloud with the help of lightweight functions. We can compose them together. The main objective is to reduce the amount of servers that I have to maintain to stand up a service. But I want to employ as many other people's services as possible. So it has this kind of greedy aspect to it. I want to consume the web as much as possible and this diverse web of services and compose them together in interesting ways with the help of functions. So that's the basic trajectory that serverless programming has been following. And so throughout the talk, I'll try to cover most of these topics, and I'll jump around as you guys direct me to, but also I'll do things in a little bit out of order as we go forward. But I think the main place I wanted to start was in the developer experience, because I think that's actually one of the main inspirations that I found in the serverless mindset, is that it actually enables you to write complex applications in a relatively simple way, because you can think about coding the cloud as actually writing programs. And as we go forward, I'll show you a bit of that. So I want to start with something as simple as you could possibly imagine. And what I'm going to show you is a quick video. I can switch to the live version later, but I figure I'll start with something more reliable. The idea here is let's let this run. So everything you see here, I'm coding on my laptop, but every command that I execute is interfacing with the cloud. So I deployed I always do that. I have to spacebar to pause. So I deployed. How do I pause? Sorry, always mess this part up. I mess this up in my last talk too. Click on the wrong spot. Gotta aim. So I wrote a simple echo program, a function. I deployed that to the cloud. After I hit return, it was deployed. And now I have a service running the cloud that I can subsequently invoke. And so the next command that I did was to invoke that function. And so I wanted to give you a sense of just what's happening behind the scenes here, that every time I'm doing any one of these commands, every invocation, even though it looks like I'm just invoking a function, is actually invoking a service that I deployed. And the latency of every operation, from the deployment to the invocations, are all fast. We're thinking on the order of tens of milliseconds, as opposed to what might typically happen in a more conventional cloud mindset with either VMs or even containers, where things are on the orders of tens of seconds to minutes. And so I think this is a bit of a sea change, and this is a story that I want to play out here. And so this is the basic structure of the beginnings of serverless programming, is that you write functions such as this. This is my more or less my echo test. You deploy and you invoke on the order of tens of milliseconds. I think you saw there that it was on the order of human endeavor. Behind the scenes, lots of complex management is happening for you on your behalf. I had the actual process of deploying to the cloud happened just by me saying create. But also there was isolation services. In this case, the platform that I'm using is called OpenWhisk, which is an Apache project, an Apache serverless platform. It started from IBM, but now it's part of the Apache project. Red Hat and Adobe are pretty equal participants at this point. So we're using Docker as a containerization technology. So we get containerization. You didn't notice that. No part of your mental exercise of creating and invoking that application, almost time for questions, had to do with containers. I didn't have to do with load balancing. I didn't have to do with log structures, log management. That all happened for me.
Okay, 5 minutes. Do we have any questions?
First question. 2 questions, okay?
What problems are solved by this approach? For example, you showed on the beginning, but very simple method, very short. But often the code which we want to write is long, needs some encapsulation, etc., etc., and needs some, for example, authorization, authentication, and. So I imagine that this serverless approach doesn't solve any kind of problem. So what kind of problems are solved by this approach, and what are not?
Yeah. So I think this is a bit of the existential crisis I think that serverless is facing. I think it started from a technological perspective that we want to reduce the burden of deploying services. And I think it's a very common use case is that I want to glue together 2 services. I want to take as input a Twitter feed and output it to Slack or whatever. And this kind of service integration up until the age of serverless, the only way you could do that was by figuring out a deployment story. You would need to stand up a service, figure out what technology you wanted to use for that, deploy it, maintain it, make sure you have the logging, the auto-scaling, all those services, all the support services you would need to stand up surrounding those 2 lines of code would dwarf the amount of work you had to do to manage that code. So serverless was coming at it from that perspective, but you're totally right that there's no silver bullet here. It doesn't, just because you're using serverless doesn't mean you don't also need to think about my authentication scheme, how I'm doing that today. I think this is part of the challenge, I think, for us as an audience, is that if we see this as a compelling, by the way, I should say in advance that I haven't drunk the Kool-Aid here. I'm as much a skeptic, I think, as we all should be for anything that claims to solve the world's problems. But I think this is the opportunity here that if there is something compelling here from a dev experience, I've developed plenty of conventional web apps, and everything I've said, I think people who've done it will agree, hopefully, that the burden of actually maintaining a service vastly dwarfs the work you put into developing the service. And to make it stable and scalable, and you're getting PagerDuty at 2 a.m. because it went down because of some third-party thing you're using. I think there's something compelling there, and it's our job to figure out how we can backfill in all the necessary support. And the bits of service that I've described at the bottom here are just a subset of the management services we need. We need some sort of isolation, and it's nice to have that as a managed property of the system. We need some sort of scalable logging system. And those capabilities already exist in all the serverless platforms. But there's a bunch more that applications need that we need to start filling in. That's my opinion, at least. There was something else, or we can go on? Yeah, one more.
All right, so the way you showed it, the messaging semantics look like guaranteed delivery. That's not realistic. Talk to me about that, please.
Yeah. So this is a case actually where the different serverless providers, I think all the big cloud providers, the gamut, Amazon, who was the originator of this, through Lambda, Google, Microsoft, IBM, Red Hat, Adobe, they all have a play in this. Huawei, all of them. They all interpret that a little bit differently about what the actual execution semantics and guarantees are. For OpenWhisk, it's at least once, which is fairly weak. And Microsoft, with the durable functions, gives much stronger guarantees. They have exactly once. So there's a spectrum, I think, that's being played out. And the challenge is to figure out where on that spectrum we need to be. And I think it's an open question. A couple more?
How widely used is this technology today? Do you know in numbers compared to regular web servers or service in general?
Yeah, so I don't have the ratios, but I can give you some numbers. So for example, Amazon in their public filings says that Lambda is getting, I think about a year out of date, so maybe even more now, but about 1 billion hits per day. So 1 billion Lambda invocations per day. And I think that probably is vastly dwarfed by the overall load for EC2 and their other containerization technologies. But it's been on a pretty high ramp up. If you go to serverless meetups, I think there's a sense of excitement here for a lot of the reasons I mentioned, but it's certainly in its infancy. I think that's why there's a big opportunity for us all to help shape the space, because we have the expertise to do so. A couple more?
50 milliseconds. Isn't it slow?
Yes. So actually, I have a little question slide. Yeah. So yes. It depends how you define slow, but yes. For example, if you wanted to if you were doing truly echo for every, I have a bunch of slides at the end. We can get into details. We can get them now, I suppose. But if you're doing just an echo and every invocation requires spinning up a container, then the costs of that are going to vastly dwarf the nanoseconds that you would do for an invocation. So from that mindset, if all you're doing is tiny stuff, you're in trouble. From a throughput and latency perspective, mostly from a throughput perspective. But the reality is, I think, and we'll get to some details maybe later on, that I think we have a good way to address that problem. I think, and having a compositional approach to serverless functions. Let's say I wanted to sequence A, then B, then C, and each one of them is just basically echo and level of complexity. Naively, each invoke would be a separate invocation going in through the front door of the whole platform, going through the entitlement checks and the containerizations and everything, going through the queuing systems, and that's pretty expensive for every little echo. But that's an optimization problem, not a blocker. So I think there's opportunities here, and we have some work in that direction already. But you're right that there's challenges here, and so I think almost every question I think you can imagine, I think you're right. This is it's an infancy for sure.
I'm convinced already about serverless, but I have a question. So once you add a database and maybe a third-party service, how different is it from like a platform as a service?
Right. Yeah, so for me, just the terminology, platform as a service for the audience. So if you're familiar with like Google's App Engine or Cloud Foundry, these are platforms where you can write your little Node.js Express app, or not so little, and you don't have to worry about how it's shipped to the web. You just say CF push or Google's is cloud deploy or whatever it is, and you get all the platform issues. Everything below you sort of comes for the ride. And serverless, I think my main thought on that is that it's really pushing up the level of abstraction, a couple more levels up the ladder. And so with a CF application or a Google App Engine application, you still have a service that's up for all time, and you have to pay for, despite the fact that it's getting no volume at 2 a.m. in the morning. You're getting PagerDuty at 2 a.m. in the morning because something went down, you have a memory leak or whatever. So you still have all those issues. I think the opportunity we have here, I think, is that this really simplifies some aspects, not all, of the development experience. And hopefully, when I get the baton back, I'll step into some more complex examples to show you that. But yeah, it's maybe a couple more.
I have a question. So I mean, what do you do about state? I mean, you have to load state from storage every time your function is invoked, and then you have to store it back before you close, and that's 2 round trips to storage, and you can't keep anything hot in memory. That sounds really, really slow when you start. And it's already 60 milliseconds for an echo.
Yeah, so just to get us all on the same page, I think one of the main tenets of a serverless sort of platform is that each of the functions is enforced statelessness, so that it's really run and done in a very PHP kind of style. In fact, PHP really was the progenitor of a lot of these ideas. And that's a healthy, I think, mindset. I think most people who maintain large applications have navigated towards that direction anyway, naturally, that having externalized state is a healthy thing. It lets you auto-scale very easily, it lets you have failover for zero extra work. But you're right, it puts some burden on either the developer in an infant environment, but hopefully on the libraries as we go forward. So I'll show you some examples in a bit where we can actually for free get some very nice notions of lexical state without any burden on the programmer, so that within the context of a larger composition, you can get lexical state for free. But we still have this story of how we get persistent state, cross invocation state. It's a challenge for sure. Hopefully we can adjust that over time with library support.
I think there is no business that wants to be dependent on some cloud platform, right? So when we are talking about, I don't know, Docker application, we don't care about which cloud platform we use, right? So
Yeah.
when I'm using functions in my code, am I in this trouble of?
So sorry, that's a good question, but the answer is depends on your provider. So there's a number of serverless providers who are very much in the ecosystem game, and that's the real gambit, is to pull you into their cloud. So I would probably put Amazon in that camp. Their main objective is to bring you in, to suck you in. They're doing an awesome job, but I think that's their business model. There's others, and OpenWhisk is one of them, where they've taken a different tack, which is, I think, targeted, I think, really these use cases. In fact, I mean, IBM, just to be truthful, is very much has that as a business model, that we have plenty of customers that have databases on premises that are not moving for the rest of life, for the rest of the universe. That's where they are. They're on mainframe code that's never moving anywhere else. And so the strategy that we're taking is, and I think not us alone, Huawei and a couple others are taking the same strategy, is you open source the foundation. In fact, I could run a demo today and disconnect my wireless network, and I could get all the features. I could demo anything with the lexical state. Everything would run on my laptop completely disconnected. That's because I can set up the full stack, including all that stuff, the containerization, the logging, everything. The lexical, everything is all set up and running on my laptop. So I think you're right. If you make a choice for a player who's playing this game, you're in trouble, I think, if that's your objective. But it's a choice you have to make as a business of who to go with something that's more open. That's just my opinion. But it's definitely a part of the game that's being played here. My turn? Okay. Yeah, so I'll touch on some of the issues of performance as we go in a little more detail. So I think, just quickly flash up, I think as a web developer, if any of you out there, I think that part of the challenge, that we're trying to address here is this fatigue. Personally, I think Dave touched on a little bit in the last talk, that as a consumer of the cloud, it's very easy to get fatigued by 10 new APIs and services that you just must consume, coming out every 10 minutes. And I think the hope is that a lot of these are technologies. These are not, for example, Zookeeper and the Kafka. These have to do with queuing and configuration management. Those are not necessarily technologies I need to know about. For example, when I use my operating system on my laptop, I'm not thinking about how it gives me the POSIX abstractions. I just care about those abstractions. So I'm hoping that part of the serverless mantra that we can start getting out there is really pulling up this layer to hide those technologies on top of some sort of more rich programming model. Just to quickly touch on what some of the constraints are on the solution, I think these are important as we go forward and think about how we solve these problems. As I was saying, a really important part of this is having a richer and richer set of managed subsystems, exactly like an operating system would have, to deal with all the day-to-day details of having an application, from logging, message queuing, auto-scaling, inter-process communication. These are all things that a real platform provides for you with some nice abstractions, not via a bunch of technologies. Another important part of the serverless objective that we can't forget is this notion of not having to pay for idle time. And that's, as we go forward, I think that's something that we have to keep in mind. So I'll just go forward to the next bit. You've asked enough questions. I don't need to prompt anymore. So now I want to show you how we can take these primitive little simple functions and do more complex and real stuff with them. I think you'll quickly see if you use serverless that a Lambda on its own, it's like, fine, I can do some simple stuff with it. But real applications actually need to do something more complicated. So let me show you how we might do that. So I'm going to show you a quick little run through of, so this is a little preview of a more complex, a composition of functions that is something a little more complicated. It's still silly, but the idea is just to give you a sense of the more orchestration mindset that serverless can possibly help us facilitate. So in this case, we're doing something that tries to join together the Star Wars API, it's silly, but a Star Wars API and a Star Trek API. And the idea is that I want to write a new service that can answer questions about either, because that's my value add. This is business 4.0. And so, this is what a lot of the web is joining together services in unique and innovative ways that you can have a business model around. And so the cloud function approach, I think, is perfectly suited for this. But the question is, how can we take those little isolated little functions and group them together into something that's more like an orchestration? Oops, I clicked the wrong place again. So all the major platform vendors have a story here. I'll try to convince you over my remaining time is how we can have a nice programming abstraction on top of this style. So I'm going to deploy this composition, and this was in my hotel room last night. This is a cloud deployment, and I'm going to invoke it now. So each of these, the whole application is deployed. I'm introspecting over the API to this Star Wars API, and now I can invoke it. So I think this is the mindset I think we should be shooting from. So this is a cloud deployment. This whole composition, including all the dependent functions, has been deployed. I invoked it. It says R2 has red eyes. I can now look at how a little slow because I was in my hotel room last night. I can see how the data flow occurred through this particular composition for that instance of the invocation. I can do a separate query against Captain Kirk, and I can get a similar picture of its session flow when it's done. So the question is, how can we support this kind of orchestration of serverless functions, but make the orchestrations themselves still adopt all those qualities of being pay-as-you-go, of having auto-scaling and managed subsystems, and so on. And so I'll try to paint a picture of how we can do that. So the hope is that we can write code like this. Hopefully, if you have any sense of aesthetics, you'll agree that this is not the best syntax. This is the syntax that we have today. But the idea is that the point is not the syntax. We can fix that. The point is that I want to treat writing a cloud function, a cloud composition that can pull together services and little bits of glue logic to tie together all those services. And that combination itself just a program. In fact, even more so, that combination is itself a cloud function. So it has all the properties that cloud functions themselves have. And that challenge of writing a composition of functions that itself is a function is part of the design challenge that hopefully we can address. I'll skip over the details. Another nice thing that I think property that we'd like to have is that if you don't like the syntax, if you'd like to introduce new combinators, if you will, to hide some of the details of sequencing and condition checking and so on underneath some sort of macro, it'd be nice if we could have a way of doing that. So we could def macro our way into a nicer spot. So how much time do I have left?
5 minutes.
Okay.
6 minutes.
I can show you quickly a question.
Yes, please. All right, so in this morning's talk on reactive streams. The story that we heard was about vendors realizing that they're working on the same problem and coming about convergence to this API. How realistic is it to have something similar happening in the world that you're describing here with the IBM Cloud Functions and Amazon Lambdas and so on and so forth?
Yeah. So I think that, so if you look at the way the vendors are addressing this composition problem, I think there's really two camps. And one of the camps is the way you write a composition is by basically coding up an FSM in JSON. And I think step functions like that from Amazon and Huawei is taking that approach. A number of vendors are taking that approach. They haven't thought as much about the linguistic abstractions surrounding that, how we'd actually like to program that as developers. We've taken some steps in that direction, but I think it's an open question of how we proceed from here. I'm hoping that once we have initial implementation of, once we have the initial proposal of what such a abstraction would look like, we can go from there. But yeah, these things are less than 18 months since initial conception, so it's very early days for sure. But it's definitely an interesting challenge. So I wanted just in the last minute or so, I wanted to describe just some of the challenges of how we could, from a linguistic perspective, of how we can achieve this dream of having this kind of compositional approach to the cloud, but doing it in a more linguistically proper way so that we can obey all the principles I was talking about earlier. So in this case, I want to compose together two services and make a sequential composition. We can do that in a number of ways, and the vendors have taken a couple of these approaches that I'll try to tear down a little bit and dissect. But the point is that we'd like this thing itself to have all the properties of a cloud function so that we can do this hierarchical composition. Every composition is itself a function that has all the same properties that can be composed into larger and larger interesting macros as we go. So this is a sort of the step functions approach where, sorry, not a step, it's an external approach that step functions has taken and a number of other vendors. The idea here is that I do a reflective invocation of the first, and then I do reflectively invoke the second. And I just depend on the platform's semantics for doing a blocking invoke so that I can pass the result. And this logic of chaining together the first to the second is done in my browser. It's done on the client-side code. Step functions is actually implemented that way. There's an external service that just calls into the step functions API. The problem with that is that there's a bunch of challenges. You have a problem of double billing. So now you're being charged for all the time these functions were on stack and simultaneously for the time this was on stack. You also have problems that this thing itself is a different kind of beast. So you can't take this and compose it in the same way that you might think about composing the units. We could do fusion, as I was hinting at earlier. We can take the two functions and just inline them into one larger beast, which helps with performance, but we have problems that these two beasts need to be written in the same language, which is a pretty important constraint these days. We just have developers who are writing in any random languages they want, languages of the day, and that's just a mentality we need to adopt.
Yeah, about development, I mean, it's one thing when functions are fairly small, but I imagine if you have larger functions that become, how do you actually debug and develop these? I mean, if you're always deploying in the cloud, I imagine it's quite hard to use your standard tools to actually figure out what's going on.
Yeah, that's certainly a challenge. So if you're doing a true cloud-native development of such a composition, this A then B, what do you do if you're just not calling B right because B accepts some parameter, some schema that you're just not obeying? How do you even know that? B will just fail with some weird null pointer exceptions, who knows what. And it's a challenge because this orchestration is happening in the cloud. And so I think there's an opportunity here. We have some initial work on this of having some sort of just some cloud-native debugging technology that, for example, can do an attach in the middle and then offload the invocation elsewhere, for example, to your laptop. So I think there's ways we can get at this, but I think it's a huge challenge. I mean, just last week, I was doing some development, and I ran into this exact problem, that things were failing with null pointer exceptions, and I spent forever sticking in printfs. So it's primitive. This is just to be cliche here, but I mean, these are all opportunities. I think these are all challenges we know how to address. And the point is that some of them are new, but some of them are just old in a new context. And so optimization fusion, it's dataflow optimizations, remote attach. We've done all these things before. It's just we haven't done it here.
Do you see it? Hello?
Yeah, gotcha.
Do you see a role in all of this for WebAssembly?
Yes. So
Did that hurt?
So I think that so just to give you a quick sense of the way that the open source, it's called Composer and Conductor. You can search for it, IBM Composer. The basic way it works is that you have these high-level macros that via a sequence of lowering steps are eventually come down to a set of primitives that's being conducted by a cloud function that will then lower it to an FSM that is then run on top of the base infrastructure that does continuation and invoke dynamics. So that's the basic flow of things. But I think hopefully you see where I'm going here, that I think there is already a sense of a compilation path here, a primitive one. We are taking Node.js code and lowering it to an FSM and then interpreting it. So I think there's a lot of opportunities here from all dimensions. I mean, even we have every time a Node.js function starts up, all the standard requests are being reinterpreted into, and recompiled into bytecode every single time. So I think there's opportunities here along multiple dimensions to do the right thing. Am I out? Okay, 3 minutes, okay. So I can proceed in a number of ways. I can skip to some performance numbers if that would be helpful, or I can continue along that path of exploring the space of the model. Yes,
I had another question. Can you go back to that slide where you showed the two back? Yeah, one more back.
Oh, sorry, it was actually
Maybe?
very...
Oh, wow, okay, never mind. I didn't see any of these slides, no.
I had lots of backup just in case.
So the one, this one, or the next one, it doesn't matter. But this idea of having these separate functions, right? So at least from my perspective, there's two things that are being sacrificed with this style of composition. So one is that you lose any notion of consistency guarantees between the different services, right? So if I'm in the middle of one of these compositions and I've talked to service A and I haven't talked to service B yet because I'm about to make that request, I have inconsistencies. Furthermore, I mean, or rather related to the consistency question is also transactions, right? I lose the ability to have any sort of isolated transactions between services. And so that seems like that's also a big problem. So, I mean, with the state, so my concern in general with the serverless thing is that we've said this stuff is really hard to deploy and it's really such a burden on the developer, but I'm going to give up all of these safeties that I could get with a normal machine development, and I'm going to give up performance for convenience. And so I find that very concerning.
Yeah, so I think it's the right trade-off in the sense that I think that we can backfill the challenges of debugging and performance. I think those are problems that have already been solved, so we can just resolve them if need be. But it's not a deep challenge. The issues you addressed of how we can wrap a really rich notion of state and concurrency management on top of a stateless execution model. That's something that feels like a little more it's more researchy. But I think my gut tells me that it's a solvable problem. We've done some initial forays into that space, but I just turn it off. For example, remember I was writing that when combinator, these macros we can wrap on top of it. I could imagine we prototype something like this, having a macro that surrounds. So when I say, that example I had earlier, when I said this retain, so this is introducing a notion of lexical state into the model. Retain says invoke this function, but then join the input and output and pass it to the next step. So that's already, I think, gives you a hint of the kind of linguistic abstractions we can put on top of of the base foundations, but I sense skepticism.
No skepticism. It seems like a state monad in a sense, right?
Yeah, I think that's why I think, yes, I think that's the basic mindset that we have here, is that you have a stateless core on top of which you can wrap richer semantics. And to me, that feels like an interesting direction that I'd love it if we could start playing out.
So, I mean, if that's true, my final comment, if that's true, it sure sounds like we need a type system.
Come one, come all. Yes.
Just want to make a quick
Please.
comment on that. I think if you look at 12-factor services and especially microservices, that you already see that the transactions are no longer supported because every bit of your data is in a different database. You can't.
Yeah, in fact, Microsoft is, I think, ahead of the game here. There are durable functions you should look into if this is interesting to you. They have a much stronger enforcement guarantees in terms of concurrency and in terms of data integrity, because that was their price point basically. And so I don't know. I feel compelled that this space is a rich one, filled with lots of interesting hills and valleys that we can explore. 0 seconds?
3 minutes.
Oh wow, it doesn't count against my time. So did you performance numbers or more examples, live demos? Performance, okay. Yeah. Dang it. Yep. So this is I have to say, there's been a lot of, I should just done this better. There's been a lot of work in the performance. There's two problems here in a serverless context. One is because we're doing containerization on invoke. In other words, we're doing a deploy on invoke very lazily. They have what's called the cold start problem. That's just a term of the trade, which is that every time I do an invocation, the first time or the first couple of times as the system warms up, it's going to be a lot slower than in the steady state. So that's problem number one. The good news here is, let me show you, so a warm start, this is all for OpenWhisk. You can vet these numbers by downloading it and running it on whatever kube cluster you want. So the warm start number is P50 up to P99. And so this is for echo, again echo, just simplest. This is the worst case because I'm doing no work in the middle and it's all overhead. So you can see here we've done, I think this is pretty admirable work that given all the work we're doing, you can see we have issues with P99 still. I think the gold standard here is that P99 should be about 2x. So there's a lot of work to be done on our P99 numbers. But I think it's reasonable. It's a reasonable starting point. The cold start under light load is much worse, you can see here, because that has to do with containerization and starting up the Node.js runtime the first time. And under heavy load, it gets a lot worse. So there's work to be done here. But the good news is that, there's a little bit of hint of good news here, is that when we first started the project, these cold start numbers, and this is across the board for all the service providers, were on the order of 500 to 700 milliseconds. And so it gives you a sense that it's more of an engineering challenge. With some concerted effort, with the right priorities in place, these numbers are eminently tunable with extra optimizations under the cover or above board, at program level, source level, fusion, and so on. I think these are eminently tunable. To give you a sense of the costs of starting up a new container in kube without any of these extra serverless kind of supports, it really is on the order of 2 to 10 seconds. So I think we're veering in the right direction there. Question? I have another chart here, but let's get a question.
I have a question to this slide. So
sure.
It's about, there is something like warm and cold start in this serverless approach, because I understand this in such a way that every call to the function is kind of cold start, because we don't have any cache or something like this.
So you're saying that, for example, if the function needs to load some data in from the database, you would consider that a cold start?
Yes, one amount, one of three things.
So I think when I say cold starter, I mean just the cost, the overheads of getting to the point where the program is runnable. So you can execute jump to main. And so, because echo is doing nothing. So this is basically the cost of jumping to main and then getting out of Dodge and back to the client. And so the reason why the reason why we have the cold start is simply because there's extra containerization costs that you have to pay up front.
So where is the border between cold and warm start? How
I gotcha.
when I'm a programmer, I would like to know how to write a program to use this warm start facilities. And,
Gotcha. So the good news is that you don't need to program it specifically. You just need to be aware of that that point of change. So I can show you in the tooling, for example, as you do the first couple of invocations will be slow, and the trace views will show you that container initialization is explaining most of the cost. Once you invoke it 3 or 4 times, depending on the load balancing scheme, as all the containers are warming up across the hosts, you'll start seeing much faster performance. You'll switch into this regime. But I think this is one of the nice things about it, is that you don't need to, should be part of a managed system of worrying about load balancing, containerization, and so on. That's what a good operating system should be doing for us.
Audience is up time, 50 seconds. Yeah.
Oh, well, I'm happy actually just to keep on fielding questions. I mean, we can talk afterwards. There's so much to talk about here. I'm excited to spend as much time as you guys want.
So you mentioned there's a pay for what you use model.
Yeah.
So how does it work? So to be able to adhere to these numbers, you need to have some servers running at some point.
Yes.
So if you're hosting your own serverless platform, you need to have.
It's not
those
turtles all
servers
the way
running.
down. That's part of the challenge here. Yes. So there's.
So how do you scale up as well in that case?
Yeah. It's a very good point. So, so at some point, I think what you're pointing out is that the service provider needs to pay these costs. Because it.
More than that.
Oh, well, yes. So there's multiple levels of turtles in this stack. One is a level of the serverless functions. Underneath that is a level of managed containers, which is what all the serverless providers are giving you. At some point, they're going to have to do the budget analysis to figure out how they want to trade off the probability of a cold start versus a frozen start. We should call these frozen starts. Yeah. So a frozen start versus a cold start. And that's an economic decision that the platform provider needs to figure out, of how much they're willing to get customer unrest versus paying. And then down below there you have, whatever we want to call it, the cost of spinning up a new host. And yeah, so there's multiple levels of turtles here. And this is another part of the challenge, is how we can come up with an economically viable system, or is it possible to come up with an economically viable system that can do so much masking of these costs? Is that possible? Sounds like an interesting topic.
It's to do with looking at the data you have already and how many people are running functions on the cloud.
Oh, so it was So today, I think I can't talk with the way the other platforms providers do it, because I don't know the details of how they implement this. Today, IBM's approach is more on the primitive end of the spectrum, that we are only beginning to do the levels of auto-scaling at the deeper levels of the stack. And so I don't have any good numbers to share with you yet. But this is another interesting part of the challenge. If you want to come into the space, there's really, you can go about this at multiple levels, but I think that if you agree with the mindset of introducing higher levels of abstraction so that we can reduce programmer burden, then there's a lot of interesting challenges to be solved for sure.
Thank you.
Out of time?
Yeah, right.
Okay. I'm here all day. Thanks.